Watch, listen, learn. Welcome to BCC on iTunes U.
When we have detected an unexpected antibody in a patient sample, we need to identify that antibody and determine its clinical significance. To do this, we perform an antibody panel. An antibody panel is a set of 11 cells that contain known antigens in separate combinations. We carry this testing through 3 phases: immediate spin, 37 degrees, and the anti-human globulin phase, and record our results for each cell. When we have finished performing our testing and our results have been recorded, it is time to begin ruling out antibodies. The first rule in excluding antibodies is that we only use negatively reacting cells. This is not going to work. Our results are in this column over here. We look across to see where our negative reacting cells are. In this instance, our first negative reacting cell is cell number 2. It is negative in all 3 phases of testing. Using a straight edge, we isolate that line, cell number 2, and look across. Wherever you see a little plus mark, that indicates that that specific antigen in that column is present on the red cell. Zeros indicate the absence of that antigen. We begin in the left, and we look down and across with the plus cells. In this case, there is a plus for the D antigen. We can rule this out. This means that the D antigen is present on this cell, but the cell does not react. Therefore, that antigen cannot be responsible for the positive antibody screen that we have gotten. The next positive we get to is big C. We need to make sure that the antigens are homozygously expressed on the cells, which means that they're present in a double dose. We look over with little c, which is its corresponding antigen, and realize that little c is not present. Therefore, big C is homozygous. You can only rule out using homozygous cells. In this case, we can eliminate big C. We move across to little e, where it is positive on the cell, and we look over with big E and see that big E is not there. So therefore, little e is homozygous, and we can eliminate little e. The same thing with Solano, KPB, JSB. Duffy A is homozygous because it is there alone. So is JKA. You're not going to see this. Little s is homozygous. M is homozygous. And that is all we can rule out using cell number 2. And we move down to the next negative cell. We start from the left again and look for where antigens are present. D we have already excluded. We look over at big E. It is homozygous because little e is not present, so we can exclude big E. Little c is also homozygous. We did Solano. JKB is heterozygous, meaning that it is present on the cell with JKA. Therefore, we cannot exclude this cell yet. XGA. Lewis A is homozygous. P1 and Lutheran B. We move down to the next cell. Get rid of F and V. JKB is now homozygous on this cell, so we can cross that off. And so is Lutheran B. And also N. Number 5 is also a negative reacting cell. What do I have left? Here we have Duffy B, again heterozygous. So we cannot rule that out. And S is also heterozygous, so we cannot rule that out yet either. Nothing that we can rule out on this cell. Cell number 8, I'm sorry. Here we have S, again heterozygous on a negative reacting cell. If you are unable to find a homozygous cell for S, it is acceptable to use two heterozygous. Remember that up here on cell number 5, it was also heterozygous. Now we have it here, so it's acceptable to rule out S. There's my Duffy B. Cell number 9 we cannot use because it is positive at the anti-human globulin phase. Going across. Duffy B is homozygous, so we can rule that out. Now we cannot rule anything else out. After we have ruled out everything possible, we need to look at what antigens remain. In this case, the only antigen of concern is Kel. In order to prove that Kel is here, we need to look at the pattern of reactivity. Kel is present on cells 1, 7, and 9 only. If we head over here to where our test results are, we notice that we have positive reactions on cells 1, 7, and 9. Therefore, at this point, we can identify our antibody as anti-Kel.